Then what's next? The tiling, this tiling, makes texture tile in this way, and then the other one in this way. So nothing like special there. Just be aware that if you change the U tile, you sometimes get this seam over there. That is normal, and you just need to find a number that works for you in the amount of tiling with your current texture in order to eliminate that seam. Okay, just pay attention with that and be careful with it. This styles it like inwards, which is super cool. And I want to do a really quick cleanup, as I mentioned. So like if I'm saying that this appearing when you change the U is natural, you might in the current setup actually get a seam around there while you're observing your effect in here. And by the way, let's actually go down here, select our plane that we worked so hard on in the previous chapter, and drag the effect up there. Look at that, super. And you can actually see exactly what I was trying to tell you. Do you see this line? There's YouTube compression going on, so it might actually be incredibly hard to see, but I'll try to pause the video in a second or a play, in a second or a play, in a second or and show you the line. So that line, let's fix that line. The way this line appears is due to something called Mipmapping. So the way game engines work is we have an object and a texture on the object, and that texture, when you're up close, is your original texture. Let's say that I created this Berlin noise and it is 4K texture. I am super close to it, my camera distance is very close to it, so it loads the highest Mipmap, which is the 4K. But the engine in the background actually creates a pyramid of lower Mipmaps, and those are the texture shrunk down. If this is 4K, then the next Mipmap will be 2K, the one after 1K, the one after 512, and so on, up until like a really small one. And when the camera distance increases with the player moving, it automatically switches to different Mipmaps. That way, we get texture streaming, where we can be looking at an entire scene, an open world of tons and tons of different things, but in memory we really load just a lower Mipmap representation, because a 4K texture is larger in size in its memory representation than 512, for example. So that's why we have something like Mipmapping. It also gives us other benefits, because our screen, the player screen, everyone's screen really, is a pixel grid. You have a bunch of pixels on a 2D matrix. And if eating a noise that is highly detailed and overly sharp, and that texture has some kind of a grid pattern that is happening on it, like the artist made it that way, let's say that it has some type of like sci-fi grid. What might happen is that with camera going further back and back, if this texture was left to always be a 4K incredibly sharp one, the grid of the pattern that is on the texture might align in such a way with the grid of the screen of the viewer that there might be a glitchy patterns happening on the screen. Those are called Moire patterns. I don't really have any way to show them to you right now, but I might try to put on the screen some examples of Moire patterns. Moire patterns, we eliminate them thanks to Mipmaps, so that is another benefit to Mipmap. But in this case, the Mipmaps actually give us an issue, and they create that seam over here with us moving in and out. So we need to solve that. Perfect, so let us change the Mipmaps and fix that seam. So the way I do that is I click, the Mipmap control is in here, by the way, or in the texture object itself. We will not go to the texture object itself because this is a derivative from the engine and it is a default thing that we don't want to change. Instead, we right click here, and we don't right click, we just click on it. And here, Mip value mode, we go to derivative, okay? Explicit derivative to compute Mipmap levels. And it gives us an error because it exposes DDX and DDY of the UVs. And in order to fix that, we will add texture coordinates, okay? And then we'll say ddx for utility, and then ddy. We input each of these in here, and the x goes up there, the y down there. Cool. And let's place that here, save. And there we go. Now the seam is not there. So we fixed that, and that's perfect. Again, though, to repeat, this fixes the mipmapping issue. If you change this to a value that is like imperfect, there will be a seam. That doesn't have anything to do with the mipmap explanation. That is just normal. Cool. So let's save and let's go here. Perfect, so we're done with that part. So in order to give it this blue appearance that I have there, we need to feed it an actual texture. We'll do that in a few steps though, because before that I have a few other things that I want to do as housekeeping. And then it's raining outside and I hope my microphone doesn't go crazy. Well, it's raining crazy much, so sorry if there's noise from here on.